Okay, let's work a little bit on rates of change. So this question wants to talk about average velocity and instantaneous velocity. So the position of an object moving vertically along a line is given by the function s of t equals negative 4.9t squared plus 30t plus 20. And it says find the average velocity of the object over the following intervals, and then make a conjecture about the value of the instantaneous velocity at t equals 2. So if you remember from the notes, average velocity is really just the slope. So to find the average velocity over the interval 2 to 3, I want to do the slope between the point x equals 2 and x equals 3. So I'm going to do s of 2, those will give me the y values, s of 3 minus s of 2 divided by 3 minus 2. Similarly, for this interval, I would do s of 2.5 minus s of 2 divided by 2.5 minus 2. So what I'm going to do is I'm going to take these values, 2, 3, 2.5, I'm going to plug them into this function. And to do that, I'm going to make a table. So to make a table in your calculator, you go to the y equals and you type in your equation. So I typed in negative 4.9x squared plus 30x plus 20. And I'm going to go to my table settings because I want it to ask me what the independent variable is. And when it does that, it lets you type in any numbers you want for the x. So I'm going to go to my table and I'm going to type in these values I need for x, like 2 and 3 and 2.5. And notice every time I type in an x value, it spits out to me the y value, or the value of the function at that point. Okay, so if we keep going with our average velocities, I need s of 3, which is 65.9, minus s of 2, 60.4, divided by 3 minus 2. So I get 5.5 divided by 1, or 5.5. The average velocity between time 2 and time 3, or the slope of the secant line, is 5.5. Okay, do the same thing for the second interval. So s of 2.5, remember my table is telling me this, 64.375, s of 2, 60.4, divided by 2.5 minus 2. So plug that in your calculator, and you should come up with like 7.95. Let's see. Second quit. 64.375 minus 60.4 divided by, I'm going to use parentheses, 2.5 minus 2 gives me 7.95. Okay, keep going. So now notice my intervals are getting smaller and smaller. So the distance is getting closer and closer to 0, or the 2 points are getting closer and closer together near 2. And what that does is help us see what the instantaneous velocity right at 2 might be. Okay, so I'm going to put 2.1 in my table, and I'm going to put 2.01 in my table. So back to my table, I'm going to put in 2.1 and 2.01. And notice I got 61.391 and 60.504. So this becomes 61.391 minus 60.4 divided by 2.1 minus 2. And this one becomes 60.504 minus 60.4 divided by 2.01 minus 2. Okay, again, go ahead and put those in your calculator and see what you get. So 61.391 minus 60.4 divided by, parentheses, 2.1 minus 2, close parentheses, gives me 9.91. Do the other one. 60.504 minus 60.4 divided by, parentheses, 2.01 minus 2. 10.4. So here I have 9.91 and 10.4. So if I'm going to make a guess, I would say that the instantaneous velocity keeps getting bigger and bigger and bigger. And I'm going to say it's about, this was 10.4, right? So maybe 10.5. We could do a smaller interval. We could do 2.001. That's 60.41. So 60.41 minus S of 2 again, 60.4, divided by 2.001 minus 2 gives me 10. Oh, so maybe we're going to say 10. It's just sort of bouncing around. So let's make our estimate even better. About 10. Okay, that's average rate of change.